Hey everybody. Alright, I'm going to get started with this refrigerator test. Let me show you what I'm using for it. Got a 30 watt panel here. Let's see here. You probably can't read it. It's almost completely faded out. It's got some rubber roof sealant stuck on there. This thing's old. It came off of a 1995 camper that I bought. And I have no idea what year the panel was made. I don't see any dates on it or anything, but it's old. It's old technology, and it's more of just a maintainer. It says right here, I don't know if you can see that, it says 30 watt panel, actually right there, 30 watt panel, 1.78 amps at 47 degrees Celsius. So a 30 watt panel, it's more of just a maintainer panel than it is a charging panel. I don't know for sure, but I think it looks like monocrystalline cells to me, but it doesn't say on the back if it's polycrystalline or mono. I think they're the mono cells just by looking at them. They kind of have that crystal-y look to them. There's my battery box. I'm going to use this battery right here for the test because it's kind of a smaller battery. It doesn't say how many amp hours it is, but it's Interstate, which is a good battery. It's a 3-year-old battery, 9 of 14, and it's a Group 24 DC for deep cycle, I suppose. It says Marine RV. It's not a true 6 volt DC or deep cycle, but it's kind of a both dual purpose. Dual purpose. Anyway, the cells are up to par as far as water goes. I just rigged up a 12 volt socket on here. This is an old socket I took out of my old previous van build. When I built that thing, I found this socket in there, and I just thought I'd keep it and use it for tests like this. A Group 24, is that what I said? I think it's a Group 24 battery. Yeah, 24 group size. So the other batteries that I've typically been using are 100 amp hour or 106 amp hour Group 27. So this is a smaller battery, and it doesn't say the amp hours, but I'm going to guess this is between 75 and 85 amp hours probably for the test. And this is also a charge controller that I took off the top, or took off that old camper when I pulled this solar panel off of it. This is just a, I don't know what you call it, a bus bar, I guess. Connects the panel to the charge controller. And this is old technology too. This is an old Solar State SRX-6/12 SolarX. It says 12 volt DC, 5.5 amps. And all this does is it's got two lights, an amber light and a green light. It flashes the amber light, or the amber light is not flashing, it's solid when the battery is charging, and when it's full it turns the green light on. So I'm not going to get a huge amount of information, but I will know if it's charging or if it's full. And then just a couple of real grungy, corroded up alligator clips that I'll be using to connect the solar panel to the battery. So let me get this set up in the van next to the refrigerator, and then I'll show you what I'm going to do. My plan, hopefully that lighting's decent. My plan is to just run the refrigerator completely empty. I'm keeping it set where I had it set before. I think I had it set for 35 degrees Fahrenheit. It is it is warm. I mean, the refrigerator is not cold at all. It's 1:15 in the afternoon, and let me see what the temperature is. Well, the fridge will have a temp gauge on it, but let's see just for kicks. It says 84 degrees outside right now. So I'm going to go ahead and start it on this battery and see if the battery can bring it down to temperature without losing all its power. At the same time, I'm going to have the solar panel connected, and I'm hoping that by the time the sun goes down tonight, the battery is charged back up to full, but I don't know that it will be. I guess that's why I'm doing this experiment. And then I'm going to let it set in the van all night, running, of course with the solar panel outside, and see what the battery is reading in the morning. All I can do is check the battery with the voltmeter. I don't have a system set up like I do in the camper where it can tell me percentages and all the fancy stuff. So I just either know it's charging or it's not charging, and I'm going to have to gauge this whole test based on just voltage. 12.2, I want to stay at or above 12.2 on the volts at any point throughout this test. I guess that's going to be my bottom line gauge to determine whether or not it's going to be a success or not. And with the refrigerator being completely empty, that's its least proficient state. If you have it packed full of food, it'll hold the temperature much better and run a lot less than what it would if it's just completely empty. So let me get that set up and then I'll show you what it looks like. Okay guys, I just set the refrigerator in the back of the van here like that. That's probably not where it's going to stay, but just for the test. And then I've got my battery in its container in case it leaks anything. And I forgot to do this earlier, so let's do it right now. I'm going to try to set this camera here and show you what kind of voltage it's setting at right now. It's fully charged. It's been sitting on a maintainer for months and months since I pulled it out of the camper. And I'm going to put it, actually it's been sitting off of the charger for at least a couple hours. So this is the true voltage where it sits right now. 12.78. 12.79. Okay, now what I'm going to do is plug my refrigerator in. As you can see, it's not on. I'm going to plug it in to this socket here. I don't have enough hands. Let's try that. And there is a fuse in this plug, by the way. Hopefully I don't need it, but there is one. Okay, I think that's plugged in. That just plugs down in the side of the fridge. That's the 12 volt plug. There's also a 110 volt plug which is currently unplugged. Alright, let's turn this thing on. If I can remember how. It says it's 69 in the refrigerator right now. And I heard it just kick on. So the refrigerator is running. Let's go back and do a test here. What do we say? 69 degrees. Okay. Let's see where the voltage is on the battery now. Now that I have the refrigerator running, I'm sure it dropped it down quite a ways. $12.40 and decreasing. When it first kicks on, that's when it draws the most power. By the way, the 12.2 I talked about earlier, I'm not worried about that if it's actually running at the time. I just don't want it to sit at 12.2. Alright, it's still going down. Now let me hook up the solar panel. I've got it sitting face down right now over there. And make sure I get this right. We got positive over here and negative over here. All right. And I have the solar panel laying upside down right now, so I'm not expecting to see anything. So let's set it up. Something like that, so it'll catch afternoon sun. And what? Well, it's hard to say with this sunlight. I'm gonna have to mess with this for a minute and see if I can figure out what's going on. Hold on a minute, guys. It's just hard to see with the light because of the bright light, but it's showing green right now, so it's showing fully charged. Which is interesting because it's sitting at about 12:15 under power. I can still hear the refrigerator running. So 12:15, 12:16 is the lowest. It's gone down to 12:15. It's 1:30, so I'm going to check this in about an hour, and it should be getting pretty close to temperature. It's gone down 1 degree is all so far. So we'll let that run for an hour and we'll come back and have a look at it. 15-minute check. 53 degrees inside the refrigerator. And let's look at the voltage. 1224. And it's going up slowly. The colder it gets, the less it has to work. Alright, we'll come back and check it again in 30 minutes. Okay guys, it's been just over 30 minutes. But I wanted to film this because I might get lucky and be standing here with the camera running when this thing shuts down. But right now it's down to 37, so that just took less than 45 minutes, maybe 35 or so. 37, and it's still running. I can hear it. And our voltage is 1227. I just checked the settings on the refrigerator, and best I can tell is I've got it set to shut off at 38 degrees, and it's showing 37 right now, so that's kind of interesting. I'm not sure. It goes a couple degrees below, I think, where you have it set, and then it shuts down. So I'm hoping I can catch this, and we'll see what happens. There we go, it just shut down. The refrigerator temperature is showing 35 degrees, and as you can see, the voltage is coming up. So I'm just going to watch this for a minute or two and see if it stabilizes. Now it is being charged by the solar panel is in full sunlight right now. I don't know if the angle on the panel is correct or not, but it's not in the shade. 1247. I want to get my phone out and see where, look at my clock and see how we are on time. Now it took about 35 minutes at 84 degrees for it to cool down That's pretty darn good off this little battery. And it's bounced back now to 12.53, which is pretty good. And it's going to continue to go up until it kicks on again. So I'm going to let it go like this. Whoops, bumped my cord there, my ground wire. 12.58. 12.6 is a fully charged battery, so it's just darn near there. 12.6 to 12.8. Wow. Here's the sorry about the camera, guys. Got it all wrapped up in that cord. So there's the temperature on the refrigerator. 35, 12.8 or 12.6. So what does that tell me? That's worst case. I mean, I shouldn't have to cool it down from 69 degrees just overnight, but if I did, it would only take 30 minutes to have that, to do that. And when I have full sun on that panel, it doesn't take it long to recover. I'm going to let this run like this for a few days. The big test is going to be in the morning after it's sat all night without any solar power, and it's kicked on and off throughout the night to maintain the temperature, especially with no food in there. I don't remember the numbers. I read a bunch of numbers on this stuff at one point in time, but it's been too long. 20% of the time per hour, it runs 20% at a particular temperature. So depends on how much you're in and out of it. But we'll see. I'm going to leave that solar panel set up where it is. It's not going to catch direct light or anything first thing in the morning, but as soon as I get up, I'm going to come out here and check this battery for voltage. I'm not going to change anything. I'm going to leave it all set up just the way it is. I may check it again a little bit later after it sits here for a couple hours and just see what my battery battery voltage is reading. But anyway, I'm all grunged out. I've been painting all day. I got all of my stuff painted. I just still have some touch-ups to do, but I'm not going to show you on this video. Got to do something to keep you coming back, right? But it looks completely different, so can't wait to show that to you guys and see what you happen to think about it. Let's see what it feels like in the fridge. Yep, nice and cool. I may put a couple of soda pops in there so I can drink them later. Don't look over here. But this refrigerator, I forget what the cubic is, 50 cubic centimeters, I don't know. It's got all that area right there for storage. This thing lifts out so you can take it in the house and load it up and then bring it out here and set it in. And then this side is a little bit warmer area, but that's where we put like our cheeses and stuff like that. Alright guys, well, we'll check this a little bit later and I'll let you look and see what it's like. I'll probably include all of that on this particular video. And then over the course of the next couple days, I'll just be doing little checks on it, probably in with my regular videos to see how it's doing. Let's look one more time. It's down to 33 degrees now. Surprising because I just opened it. That's the beauty of a top door instead of a side door. 1282 on that battery right now. Wow. Hasn't even been 45 minutes from when I plugged it in and turned it on. So that's a good battery. This thing is really holding its power. But 1283, heck, that's fantastic. Of course, it is plugged into solar right now, so that thing puts out like 14 or 15 volts or something like that in the sun, and 1.75 on the amps, I think. So we'll see how it goes. I'm anxious to see how it turns out. Thanks for checking in, guys. We'll see you on the next one.